Come on, my dears, let us proceed further in chapter number 8. Today we will finish the entire syllabus. Kindly read this statement of MCQ number 7 in the exercise. Read it? Fine. As shown in the figure, we are given two pulses having opposite shape. First pulse is in the form of a trough, second pulse is in the form of a crest. The distance between them initially is 10 centimeter and they are heading each other, that is, they are propagating towards each other. Fine. With the same speed, and that same speed is given to us 2.5 centimeter per second. Fine. At the end of 2 seconds, what would be the situation, what would be the condition, what would be the shape produced in the string? That is what we have to find out. Distance travelled by first pulse, I am taking d1, it is constant velocity into time. Constant velocity is 2.5 centimeter per second. Time is 2 seconds, product is 5 centimeter, correct? Similarly, for second pulse also in the same time it covers same distance because its speed is also same. So distance travelled by first pulse is 5 centimeter, distance travelled by second pulse is also 5 centimeter. Now tell me, these both the distances are equal, 5 centimeter each, correct? So first pulse is travelling towards the right hand side, second pulse is travelling towards left hand side, and they both cover 5 centimeter distance. So finally what will happen after 2 seconds, they will be just superposing on each other at the midpoint of this separation, correct? That midpoint I have taken as point P, and when they superpose, you can see in the diagram, one is in the form of a trough, another is in the form of a crest having equal amplitude. So according to principle of superposition, the resultant displacement produced in the particle at point P would be according to principle of superposition. It is y equals to y1 plus y2, but y1 is minus a because it is in the form of a trough. Trough means downward, downward displacement means negative, and plus y2. y2 is plus a because it is in the form of a crest. Crest means vertically upwards, that is positive displacement. Now minus a plus a will be 0. If resultant displacement produced in particle P is 0, meaning thereby that particle will remain at the same equilibrium position. I mean to say the situation or condition or the shape produced in the string would be like this, in which you can see the resultant displacement in particle P is 0, the string will remain horizontal. So out of the given 4 options, in whichever option they have shown this sort of shape, that is the correct answer. So right now this is the correct situation or shape produced in the string. Okay, fine. Kindly read this statement of number 8. Read it? Come on. Equation of stationary wave, they have given y equals to 10 sin 100t cos 0.01 x. X and y are in meter and t is in second. Match this with the standard format of the stationary wave equation. Y equals to, you should write first as 2a, then sin, if they are giving, then you also should write sin, and coefficient of t you should always match with omega. So here you should write omega t. Then if they are giving cos, then you should write cos. Coefficient of x should be matched with k, wave vector. Come on, instead of this I am writing k x as it is, correct? So this is the given equation representing particular stationary wave, and this is the standard format which we know, correct? Now just compare. If you compare, then omega is 100 radian per second and k is 0.01 radian upon meter. Now they have asked about wave velocity. What is wave velocity? Formula v equals to f lambda, and another formula was v equals to omega upon k. V equals to omega upon k. Omega is right now, come on, 100 radian per second. K, wave vector, is 0.01 radian upon meter. 100 upon 0.01, answer is 10:4. And because all the values you are taking in SI unit of velocity would be meter per second. Simple. Read number 9. Read it? Fine. The linear density of mass for a string is mu equals to m upon L, that is total mass upon total length, that is mass per unit length. This mass of the string they have given 0.035 kilogram, length of the string is 7 meter. This upon 7 is 0.005 kilogram upon meter, correct? Now tell me, if you have got a string which is stretched and kept under proper tension, and in that if you produce transverse harmonic wave, what is the speed of the transverse wave? You must have remembered the formula, v equals to under root of t upon mu. Here it is, v equals to under root of t upon mu. This is wave velocity, this capital T is the tension in the string, and mu is linear mass density. Come on. This capital T is the tension they have given in the statement 60.5, that many Newton, and value of mu in SI unit we have found out 0.005 kilogram upon meter, correct? When these both the values are in SI unit, naturally velocity will be obtained in meter per second. If you simplify, answer is 110 meter per second. Okay. Kindly read now number 10. Read it? Fine. Y equals to 2a sine of kx into cos of omega t. This is the equation which represents stationary wave, correct? And don't you know amplitude of stationary wave? It is given by formula we had studied in theory. A dash equals to 2a sine kx. And now if I want maximum amplitude, I should write a dash maximum. But then you know maximum value of sine function is 1. So 1 into 2a, that is 2a. Correct? Don't you know this result intensity of any wave is definitely directly proportional to square of its amplitude. The way intensity is proportional to square of amplitude, similarly maximum intensity is directly proportional to square of maximum amplitude, and that maximum amplitude is 2a. That's why I am writing here square of 2a. Correct? I repeat, if intensity is proportional to square of amplitude, then maximum intensity is proportional to square of maximum amplitude, which is right now 2a. Correct? Now simply take the ratio I upon I dash maximum, I upon I dash maximum. It should be equal to this upon this upon this. Correct? A square upon 2a square, that is 4a square. Correct? A square upon this means a square upon 4a square, a square will cancel. Now find out I dash maximum, it will be 4 into I, 4 into I dash maximum is 4 into I. Now tell me, what is this? Maximum intensity of resultant wave, and what is I? Intensity of a single wave. Now in the statement they have given maximum intensity of resultant wave is x times intensity of individual wave. That is what they have given. Now just compare these two. Come on, I will be getting cancelled, giving you x equal to 4. X equals to 4. Got it? Read the statement for number 11. Read it? Come on. What do you mean by bit frequency? Bit frequency is number of bits in unit time, and its formula we had derived, it is nothing but difference of bigger and smaller frequency. It is right now f1 minus f2, correct? Bit frequency, number of bits per unit time. They are given 2 bits per 1 second. Fine. When two waves are propagating in the same medium, their velocity would be same, constant. V equals to f lambda is equal to constant. So for first wave you may write V equals to f1 lambda 1. For second wave you may write V equals to f2 lambda 2. Find out f1 from here, it is V upon lambda 1. f1 is V upon lambda 1, correct? Minus, what is f2 from here? f2 would be V upon lambda 2. f2 is V upon lambda 2, that equals to 2, correct? Now this V and this V I can take common inside the bracket. 1 upon lambda 1 minus 1 upon lambda 2, that equals to 2. Now this V as it is, 1 upon, whenever you write such a bracket, I mean in this way, you must understand this must be bigger, this must be smaller, and for that this lambda 1 should be taken as shorter wavelength, this lambda 2 should be taken as longer wavelength. Among the two values of wavelength, the shorter wavelength is this 2 meter, so lambda 1 is 2 meter, lambda 2 is longer wavelength which is 2.02 meter, correct? 2 as it is. Now find out this wave velocity, you will get the answer 404 meter per second. Got it? Read number 12 now. Read it? Come on. We are given in the statement about distance between consecutive node and antinode. Remembered from theory? Distance between two consecutive node and antinode, it was lambda by 4, and that distance they have given as 1 meter. Transfer this, so lambda will be 4 meter. Simple. Wave velocity by formula V equals to f lambda. What is f then? V upon lambda. V upon lambda. Wave velocity they have given 1200 meter per second. Lambda is the wavelength. We have found out it is 4 meter. Lambda is 4. 1200 upon 4, that is 300. Unit of frequency is hertz. Leave proper gap. Write proper symbol properly. Capital S, small z, and no full stop. Okay. Read number 13 now. Read it? Come on. We have source, S means source, L means listener. They are heading each other means they are moving towards each other with the same speed 50 meter per second. Fine. Now velocity of source means Vs, velocity of listener means Vl. Don't you know standard formula? Fl upon V plus Vl equals to Fs upon V plus Vs. Come on, FL is the frequency of sound heard by the listener. They have given 440 hertz. V is the velocity of sound. They have given 340 meter per second. And you know velocity of sound is always to be taken positive. Right now, about VL, you can see this direction is the same as this direction. Remember the sign convention? Velocity in a direction from listener to source, is to be taken positive. And because this has same direction, I should take value of VL as positive. So value of VL, they have given 50 meter per second, I should write plus 50 meter per second. This frequency of sound originated from the source, we have to find out. Okay, so leave it as it is. This Vs, come on, Vs you can see it is opposite to this direction. Opposite to this direction, then value of Vs should be taken negative, correct? They have given 50 meter per second, I should take it negative. So minus 50 meter per second, correct? Fine. Now simplify, you will get the value of Fs 327 hertz, correct? See here they have asked this frequency, correct? They may give you same statement in the examination, but they may ask what is the increase in the frequency as experienced by the listener. Then in that case, to find out that increase in frequency, what you should do? You should subtract 327 from 440. So your final answer in that case would be 440 minus 327. Okay. So please read the question carefully. Try to understand what is really asked. Accordingly, you prepare the answer. Please don't mug up any value. Okay. Read number 14 now. Read it? Come on. The fundamental frequency in case of closed pipe. Remember the formula? F1 equals to V upon 4L. Correct? That fundamental or minimum frequency they have given 512 hertz in case of closed pipe. Now if the same pipe having same length is now made open from both the ends, then it would become open pipe. For open pipe, the fundamental frequency I just show it by symbol F1 dash because it is different than this. Okay, I am putting different symbol F1 dash. And by formula you know from theory it is V upon 2L, V upon 2L. Because the air column in both the pipes is same, because the medium is same, wave velocity should remain same. Because they are talking about same length of the pipe, here also L, here also L, correct? Now tell me, can you rewrite this V upon 2L as 2 into V upon 4L? Yes, we can write, because 2 2s are 4, correct? So this you can rewrite as 2 into V upon 4L. Now this 2 as it is, what is this V upon 4L? Instead of V upon 4L, I can write 512 hertz. So instead of this, I am putting the value 512 hertz into 2. That answer is 1024, that many hertz. So remember one general result from this. If you have got same length for closed and open pipe, then fundamental frequency in case of open pipe is double than fundamental frequency in case of closed pipe. Remember this result, okay? Read number 15 now. Read it. Look, for closed pipe, don't you know the fundamental frequency is F1 equals to V upon 4L. V upon 4L. Remembered? Fine. Now, when the air column in the closed pipe forms first resonance, experiences first resonance, meaning thereby the resonant frequency should match with this frequency. Correct? Now, resonant frequency is the frequency of vibration of branches of a given tuning fork, which they have given 264 hertz. Correct? So, this frequency is 264 hertz. Correct? Here they are talking about first resonance. Suppose in the examination they may ask about, say, second resonance. In case of second resonance, what you should write? For first resonance, the way you are writing F equals to F1. For second resonance, you should write F equals to 3F1. F equals to 3F1. Remembered? For closed pipes, which were the possible frequencies? F1, 3F1, 5F1, 7F1, dash, dash, dash. Remembered? Fine. So, if they are giving second resonance, you should take that possible higher frequency which is higher than F1 and which is possible, it is 3F1. Okay, please remember. Right now this frequency is 264 hertz and this wave velocity they have given 330 meter per second. Suppose I want to find out this length in centimeter, then this velocity I should convert from meter per second into centimeter per second. Meter to centimeter multiply by 100. So just multiply by 100, correct? 4L as it is. And now find out L from here, you will get 31.25, that many centimeter. You know why I did like that? Because the values of length they are given in the options in centimeter. That's why I need value of L in centimeter. That's why I must convert this velocity from meter per second to centimeter per second. I must multiply by 100 here. Correct? Now this length is 31.25 centimeter. But mind well, this is the length of air column in the closed pipe. Got it? Fine. Read number 16. Read it? Don't you know velocity of sound in gas or in air medium is directly proportional to square root of its absolute temperature. And when it is a question of direct proportionality, don't you know V1 upon V2 equals to under root of T1 upon T2. This velocity as it is. Second velocity they have given root 3 times first velocity. Root 3 times first velocity. So V2 is root 3 into V1. First absolute temperature T1 as it is. Second absolute temperature is greater than first temperature by 600 Kelvin. So T2 they have given T1 plus 600. Correct? Second temperature is higher than first temperature by amount 600 Kelvin. Fine. And now V1 will get cancelled. Take squares on both the sides. Square of 1 upon root 3 will be 1 upon 3. When you take square on right hand side, this square root will vanish. T1 upon T1 plus 600. Simplify, find out T1, it is 300 Kelvin. Okay. But because this first temperature they have given in degree centigrade, we must convert Kelvin into degree centigrade. For that, you should subtract 273 from this Kelvin value. 300 minus 273, that is 27 degrees centigrade. 27 degrees centigrade. Okay. That must be the initial temperature. Got it? Read number 17 now. Read it? Come on. Equation for first component wave in the phenomenon of bits. They have given y1 equals to a sine 2000 pi t. For second wave, y2 equals to a sine 2008 pi t. Fine. And now, let us find out omega 2 minus omega 1. Don't you know omega means angular frequency? It is nothing but the coefficient of time in the bracketed part with periodic function in terms of time, correct? This is the function which is periodic in terms of time, and its coefficient of time will give you angular frequency. Come on, it is 2008 pi. So omega 2 is right now 2008 pi. Similarly, omega 1 you can find out from here in the equation of first wave. Come on, coefficient of time will give you angular frequency which is 2000 pi. This is omega 1, this is omega 2, correct? Come on, omega 2 is 2008 pi minus omega 1 is 2000 pi. This subtraction would come out 8 pi. Omega 2 by formula you know it is 2 pi f2 minus omega 1 is 2 pi f1. 2 pi you can take common. Inside the bracket f2 minus f1, that equals to 8 pi. Pi will cancel. 8 upon 2 is 4 hertz, correct? Remember, this f2 minus f1 will give you difference of two frequencies, and that difference itself is known as bit frequency, that is number of bits per unit time. Right now the time is in second, that's why per 1 second, then I am writing here hertz, correct? So it means to say that there will be 4 bits per second, 4 bits per second. They may ask in 1 minute, then you can just put the terms this way. In 1 second, if there are 4 bits, then in 1 minute there are 60 seconds. So for 60 seconds, it would be 60 into 4, that is 240 bit per minute. Got it? So please read the question carefully and then accordingly try to answer. Okay? Read number 18. Read it? Come on. L means listener, because it is at rest, VL equals to 0. Source is approaching towards the listener, and its velocity they are given 10th part of velocity of sound, 1/10 of velocity of sound. So I am writing V upon 10. And don't you know, according to sign convention, velocity in a direction from listener to source, should be taken positive. But because this direction is opposite to this, I must take this velocity as negative. Remember, standard formula, FL upon V plus VL equals to FS upon V plus VS. Come on, FL as it is, we want to find it out. Come on, wave velocity, V as it is, because the value is not given. This VL is right now 0. VL is 0, correct? This FS, we want to find out. Wait, we want to find out one ratio here. And this V as it is, what about VS? VS is V upon 10, but because the direction wise it is opposite to the direction shown in the sign convention, I must take its value negative. So Vs is minus V upon 10, correct? And now FL upon V as it is, and this Fs as it is, V minus V upon 10, it will give you 9 into V upon 10, correct? And now V and V will get cancelled. This denominator will become numerator, and this Fs you can bring down in the denominator on the left side. So FL upon Fs will be, come on, 10 will go up, so 10 upon 9. We were asked to find out a ratio of frequency of sound heard by listener to the frequency of sound actually generated from the source. In short, we were looking for ratio FL upon Fs, and that FL upon Fs we have found out 10 upon 9. Got it? Read now number 19. Read it? Come on. Y equals to a sine into curly bracket 2 pi into small brackets t upon t minus x upon lambda. Okay. If this is the wave equation, then you may say in this wave the wavelength is lambda, periodic time is capital T and amplitude is a. Simple. What is the formula for velocity of particle during the propagation of wave? You know, if it is progressive wave, if it is harmonic wave and if it is transverse wave, then during the propagation of progressive, harmonic, transverse wave, each particle of medium performs simple harmonic motion about its equilibrium position. And in that case, the velocity of oscillation of that particle, we had found out its formula in the theoretical part. Remember, Vp equals to a omega cos of omega t minus kx. But because you want maximum velocity, then cos function value should be taken 1. So it is a omega into 1, that is a omega. So this maximum velocity of oscillation of particle is a omega, correct? But right now that maximum velocity they have given in the statement double than wave velocity, okay, fine. Now this value, as I said just now, it is a omega, this 2 as it is. What about wave velocity? By formula it is omega upon k, Now omega omega will cancel. This 2 as it is, k wave vector it is 2 pi upon lambda. 2 will cancel, denominator will become numerator. So it is lambda upon pi now, And now we are looking for wavelength lambda. Come on, transfer this pi. Lambda equals to pi into a, correct? So when the wavelength of progressive harmonic wave is pi into a, at that time it so happens that velocity of particle, maximum velocity of particle becomes double than wave velocity, okay. Here they have given double. In the examination they may give 3 times, 4 times, whatever the value they prefer, okay. So accordingly you can make the changes, stick to the same method, but don't mug up the answer, okay. Read down number 20. Read it? Come on. Value of velocity of sound in air or gas. Don't you know mathematically? Directly proportional to square root of absolute temperature. Direct proportionality, then 1 to 1 to V1 upon V2 equals to under root of T1 upon T2. V1 as it is. Second velocity they have given double than initial velocity, 2 into V1. First absolute temperature they have given as such 0 degree centigrade. Now degree centigrade will not do because these two are absolute temperatures, correct? So I must convert 0 degree centigrade into Kelvin. Come on, degree centigrade to Kelvin, I must add 273, T2 as it is. Now V1 will get cancelled, take squares on both the sides, 1 upon 2, its square is 1 upon 4. When you take square, this square root will vanish, giving you 273 upon T2. Find out T2 from here, it will be 273 into 4. Answer is 1092, that many Kelvin. But mind well, in the examination they may ask increase in temperature. If they ask increase in temperature, you should find out T2 minus T1, that is this minus 273. Got it? Or if they may ask, this absolute temperature we have found out in Kelvin, now they may ask final temperature in degree centigrade. Then you should subtract 273 from this value. Got it? Please. Come on my dears, now we begin with the numericals from exercise. Kindly read the statement of first numerical. Read it? Fine. What is called slope of wave shape? Slope of wave shape means slope of graph of y versus x. If it is one dimensional progressive harmonic wave, then you know, if it is transverse wave, then it is forming crest and trough, correct? The shape is like sine curve, okay? Now in that case, if you plot a graph of y versus x, y means displacement of a given particle and x means position of that particle from the, distance of that particle from the origin of the wave, correct? So if you plot a graph of y versus x, the shape is like wave shape produced in the medium. And if you are looking for slope of that wave shape, meaning thereby you are looking for slope of graph of y versus x. Slope of graph of y versus x. Slope of graph of y versus x, it is nothing but dy by dx. dy by dx, correct? Fine. Now this slope value I want, it is d by dx of y. d by dx of y, but y is how much? A sin omega t minus kx. According to wave equation, y equals to a sin omega t minus kx. And now a is constant taken out, derivative of sine is cos, this part as it is. Now go inside the bracket, take the derivative individually. When you are taking derivative with respect to x, you are talking about given instant of time. So this part is constant. And when this part is constant, its derivative would be 0. Minus k. Derivative of x with respect to x, it is 1. Simple. Minus a k cos of omega t minus kx. Minus a k cos of omega t minus kx. Give it equation number 1. Wait. What about velocity of particle? You must have remembered during the propagation of harmonic wave, what does each particle do? It performs simple harmonic motion, and so it can be taken as simple harmonic oscillator, for which we had obtained the formula for its velocity, which was Vp equals to a omega into cos of omega t minus kx. Remembered? Same formula written here, a omega cos of omega t minus kx. Mind well, this is velocity of particle, not wave velocity, velocity of particle. Fine. And then wave velocity formula, I told you two formula, v equals to f lambda, and another formula was v equals to omega upon k. Now they have asked one ratio, Vp upon v. Vp upon v, that is ratio of velocity of oscillation of particle to the wave velocity. Vp is how much? A omega cos of omega t minus kx. A omega cos of omega t minus kx upon v. V is omega upon k. Omega upon k. Now this omega will cancel. Denominator will become numerator. So it is a into k into cos of omega t minus kx. Simple. Now this right hand side is with right now plus sign. Here you can think of plus sign, but instead of that plus, I am writing minus into minus. Will do, no problem. Minus into minus will become plus. Now this minus sign as it is, but instead of minus ak cos of omega t minus kx, minus ak cos of omega t minus kx, instead of this, I can write dy by dx, correct? So in place of minus ak cos of omega t minus kx, I am writing dy by dx over here. This minus sign as it is, minus ak cos of omega t minus kx should be replaced by dy by dx, correct? Give it equation number 3. Tell me what is the result which you have proved. Very simple. Ratio of velocity of oscillation of particle to the wave velocity is found to be equal to negative value of slope of wave. Slope of wave shape, correct? Slope of wave shape we have found out, it is dy by dx, correct? I repeat, ratio of velocity of oscillation of particle to the wave velocity is equal to negative value of slope of wave shape. Simple. Kindly read now number 2. Read it? Come on. They are talking about waves which are originated during earthquake. Suppose waves of earthquake are originated from this very point. That very point is called epicenter. Correct? Suppose this point is epicenter. Now during earthquake, two types of waves begin to propagate from epicenter onwards. Okay? One type of wave is called P wave, for which velocity is greater. That's why I am here putting greater, longer arrow. And another wave is S wave, for which velocity is smaller. That's why I am putting here shorter arrow. Correct? Both the waves reach to that device in which these waves are recorded. That device is called, seismograph. Seismograph. So suppose here is located this seismograph. Okay? Fine. Now this distance between epicenter and seismograph I am taking as D. Now don't you know distance equals to constant velocity into time. Distance equals to constant velocity into time. Constant velocity for P type of wave I am taking as Vp. Into time I am taking as T. Now same distance is travelled by S wave also. So similar formula you can write for S wave also. Distance travelled is constant velocity into time. Constant velocity for S wave is Vs into time. Why I am writing T plus 240? Because if this P wave is recorded in the seismograph at the end of T seconds, then this is recorded later because its velocity is less. Because velocity is less, naturally it would take more time to reach to this seismograph, correct? But that what is additional time they have given in the statement, it takes additionally 4 minutes. Now 1 minute is 60 seconds, so 4 minutes would be 4 into 60, that is 240 seconds, okay? So mind well, this T is we are taking in second, okay? That's why we are converting this value in second. Fine. Now this velocity of P type of wave, they have given 8 km per second, and this time is in second. So kilometer per second into second, second will cancel, so this distance we will get in kilometer. Now this velocity of S type of wave, they have given 4 km per second. This term as it is. Now come on, 4 2s are 8, so here it is 2t, that equals to t plus 240, 2t minus t, that is t, that equals 240, that many second. Leave proper gap, write small s, no full stop. Now put this value of t over here. Come on, start with this formula, d equals to Vp into t, d equals to Vp into t. Now this distance we have to find out. Velocity of P type of wave, they have given 8 km per second. This time we have found out 240 second. This is taken in kilometer per second. This is taken in second. Second will cancel, giving you this value of d in kilometer. It comes out to be 1920, that many kilometer. That must be the distance between epicenter and seismograph. Okay. Kindly read the statement of number 3. Read it? Come on. Y1 equals to A sin omega t1 minus kx1. What is it? Displacement produced in that particle which is located at distance x1 from the origin of wave at the end of t1 time. Okay. First displacement they have given 5 centimeter. Come on. I think 5 meter. Yes, 5 meter. First displacement is 5 meter. What about amplitude? They have given 10 meter. Sin as it is, this first time they have given 2 seconds, so it is 2 into omega. 2 into omega, first distance they have given 2 meter, so this is 2 minus 2k, minus 2k, fine. Find out sin of 2 omega minus 2k, it will be 5 upon 10. 5 upon 10 means 1 by 2, correct? But don't you know from trigonometry, sin pi by 6 equals to 1 by 2. Sin pi by 6 equals to 1 by 2. So this angle must be pi by 6 radian, correct? Fine. So 2 omega minus 2k must be pi by 6 radian. Give it equation number 1. Come on, for this second displacement, here I am writing y2, it is a sin omega t2 minus kx2. What is this y2? Displacement produced in the second particle which is located at distance x2 from the origin of wave at the end of t2 time. Fine. Now this second displacement they have given 5 into root 3 that many meter, amplitude is 10 meter, sine function as it is. Come on, second time they have given 8 seconds, so it is 8 into omega, minus, come on, second distance they have given 16 meter, so this is 16, so it is minus 16k, Now find out sine of 8 omega minus 16k, it would be this upon this, 5 root 3 upon 10, it is root 3 by 2. But don't you know, sine of pi by 3 is root 3 by 2, sine of pi by 3 is root 3 by 2. So this angle must be pi by 3 radian. Come on, 8 omega minus 16k must be pi by 3 radian, correct? Give it equation number 2. And now we are asked to find out individual values of omega and k. And for that, how to solve these two equations, I am showing you very simple. Suppose equation number 1 is multiplied by minus 4, suppose. So equation number 1 is multiplied by minus 4, okay? Then, if you multiply by minus 4 here, then it will give you minus 8 omega. When you multiply by minus 4 here, minus plus, 4 to the 8k. And when you multiply by minus 4 here, it will be minus 4 pi by 6, correct? Fine. And now, just add equations 2 and 3. Equations 2 and 3, correct? If you add these two equations, then minus 8 omega plus 8 omega will get cancelled. Come on, 8k minus 16k. 8k minus 16k, it is minus 8k. And come on, this plus this, correct? So minus 4 pi by 6 plus pi by 3, it is minus pi by 3, okay? Wait, this is for, 2 2s are, 2 3s are, so it is minus 2 pi by 3, minus 2 pi by 3 plus pi by 3, it will be definitely minus pi by 3, correct? Now minus plus, find out k, 8 3s are 24. So k will be pi upon 24, What is the SI unit of wave vector? Radian upon meter. That's why I am writing here radian upon meter, correct? Because these displacements were given in meter, amplitude also was given in meter, fine. Now from equations 1 and 4, put this value of k in equation 1. Equation 1 is this. Come on, start with this, 2 omega, here it is. Minus 2 into k. K is right now pi upon 24, and that equals to pi by 6, correct? Simplify, you will get value of omega, pi by 8, unit of angular frequency, radian per second, here it is, got it? Read now statement of number 4. Read it? Y equals to 3 sine into curly bracket 3.14x minus 314t, that many centimeter. The way they are giving the wave equation, similarly we should arrange the terms in the standard format. Come on, y as it is, instead of 3 I am putting a, sine as it is, coefficient of x must be compared with k, coefficient of t must be compared with omega, correct? Come on. Maximum velocity of particle during the propagation of wave, maximum velocity for oscillation of particle is Vp maximum. How much it was? A omega. Vp maximum was A omega. Earlier also we had used the same result. Maximum velocity for oscillation of particle, it is A omega. As such, what was the formula? Vp equals to A omega cos of omega t minus kx. When you are talking about maximum velocity, cos function part should be taken as 1. So it is A omega. What about amplitude? Right now amplitude is 3 centimeter. When you compare, amplitude is 3 centimeter. What about angular frequency? Angular frequency is 314 radian per second. Angular frequency is 314 radian per second. This multiplication is 942, and because you are using this value of amplitude in centimeter, this velocity will be obtained in centimeter per second, right? Y equals to 3 sine 3.14 into x, correct? This x distance they have given 6 centimeter minus 314 into t, time they have given now 0.11 second, okay, fine. Time is 0.11 second, this distance is 6 centimeter, simplify. 3 into sine as it is, this into this comes out to be 18.84 minus this into this is 34.54. Now this minus this, it is minus 15.7, and sine of minus theta is nothing but minus sine theta, so minus sine I can take it out. 3 as it is, sine 15.7. Now minus 3 as it is, sine of 15.7. 15.7, that value is in radian, mind well. 15.7 radian, that angle is nothing but 5 pi. If you place the value of pi 3.14 into 5, it will be exactly 15.7, correct? So this 15.7 can be replaced by 5 pi, that many radian. Now minus 3 as it is, sine of 5 pi, it is 0. So 0 into this will be 0, correct? What about acceleration? Now tell me, during the propagation of harmonic wave, each particle performs simple harmonic motion. So it can be treated as simple harmonic oscillator. And in the previous chapter to this, you have studied the formula for finding acceleration of simple harmonic oscillator. What was that formula? A equals to minus omega square y. Remembered? A equals to minus omega square y. Minus omega square as it is, y value is right now 0, into this will be 0, correct? Now read number 5. Read it? Come on. We are solving this sum first using long method and then using short method also I will show you, okay? You know V equals to F lambda. Here frequency is constant because it is the given frequency of the tuning fork, which is 250 Hertz, which is constant. The moment you write here lambda 1, here you should write V1 because you are talking about velocity of velocity of the wave in the first condition. Velocity of wave in the first condition I am taking V1, where its wavelength I am taking as lambda 1. Come on, frequency they have given 250 Hertz, first wavelength they have given 1.32 meter. This multiplication is 330 meter per second. Don't you know V is proportional to under root of T. Velocity of sound in air or gas is directly proportional to square root of its absolute temperature. From this direct proportionality relation, can't you find out this? Mathematically, V1 upon V2 equals to under root of T1 upon T2. 1, 2, 1, 2. Got it? Now, this V1 is 330. V1 is 330 upon V2 as it is under root of T1 upon T2. First temperature, they have given 0 degree centigrade plus 273. So, it is 273 Kelvin. Second temperature, they have given 27 degree centigrade plus 273. So, it is 300 Kelvin. Simplify V2, you will get 345.93, that many meter per second, correct? Now, the way you could write here V1 equals to F lambda 1, similarly for second condition you may write V2 equals to F lambda 2. V2 equals to F lambda 2, correct? Come on, V2 equals to F lambda 2. Wait, frequency is constant. So, if wavelength will change, wave velocity will change. So, V2 equals to F lambda 2. This right hand side as it is, frequency they have given 250 Hertz, lambda 2 as it is, this right hand side also as it is. Find out lambda 2, it is this upon this, answer is 1.38372, that many meter. But what have they asked? Increase in the wavelength. So, I should find out lambda 2 minus lambda 1, greater value minus smaller value, okay? Greater value is this 1.38372 minus smaller value is lambda 1, which is 1.32. This minus this comes out to be 0.06372, that many meter, okay? This is bit long method. Let us now adopt the second, which is very easy method. Look, short method is this. V equals to f lambda. When given frequency is constant, because f is constant right now, V is proportional to lambda. And when V is proportional to lambda, mathematically from this what you will get? V1 upon V2 equals to lambda 1 upon lambda 2. V1 upon V2 will be lambda 1 upon lambda 2. Simple. Don't you know this? V proportional to under root of t? Yes, we know. Then direct proportionality, then 1 2 1 2. V1 upon V2 equals to under root of T1 upon T2. V1 upon V2 equals to under root of T1 upon T2. But what is V1 upon V2 from here? It is lambda 1 upon lambda 2. Correct? Fine. Now this first velocity, look, this under root of T1 upon T2. Under root I have written here. Correct? This first temperature they have given. First temperature 0 degree centigrade plus 273, that many Kelvin. Second temperature they have given 27 degree centigrade plus 273, so it is 300 Kelvin. First wavelength they have given 1.32 meter. Second wavelength I want. You will get value of lambda 2 1.38372, that many meter. And now increase in the wavelength will be lambda 2 minus lambda 1. Lambda 2 is 1.38372 minus lambda 1 is 1.32. This minus this, answer remains same, 0.06372, that many meter. Earlier also we had got same answer, correct? But this method is very short, okay? Here the value of frequency which they have given is not getting utilized, okay? Many times they may give you additional unnecessary some values, just to make you confused, but do not get confused. You will not get confused provided you know this short method or you have done enough practice, okay? Do that. Read now statement of number 6. Read it? Fine. Take hydrogen gas as first gas, oxygen gas as second gas. At present they have given velocity of sound in both the gases same. That's why I am putting mathematically V1 equals to V2. These two velocities they have given same. You know velocity of sound in gas or air, it is given which relation with temperature. What was that? V equals to under root of gamma RT upon M0. V equals to under root of gamma RT upon M0. V equals to under root of gamma RT upon M0. V equals to under root of gamma RT upon M0. Now values of gamma are same, though they have not given, but we should take same because both of them are diatomic gases for which value of gamma is same. Universal gas constant is definitely same. What about first gas? I am taking here temperature as T1. Its molecular weight I am taking M01. For second gas I am taking absolute temperature as T2. Its molecular weight I am taking M02. Take squares on both the sides. So this square root will vanish, giving you gamma RT1 upon M01 equals to, when this square root will vanish, then gamma RT2 upon M02. Gamma R getting cancelled from both the sides. T1 upon M01, here it is. T1 upon M01 should be equal to T2 upon M02. T2 upon M02, correct? T1 as it is, M01 as it is, T2 that is absolute temperature for oxygen gas. For oxygen gas they have given temperature 1200 degree centigrade plus 273, that many Kelvin. This is molecular weight for oxygen. They have not given molecular weight directly, but additional information they have given in the statement that density of oxygen is 16 times density of hydrogen. You remember, as many times density, exactly that many times molecular weight. So if density of oxygen is 16 times density of hydrogen, meaning thereby molecular weight of oxygen is 16 times molecular weight of hydrogen. So molecular weight for oxygen is 16 times molecular weight of hydrogen. Okay. Now M01 getting cancelled. Now this T1 as it is, and this plus this, it is 1473 upon 16. Answer is 92.0625, that many Kelvin. But because they want temperature in degree centigrade, from Kelvin to degree centigrade, we should subtract 273. So subtract 273 from this value, you will get the answer minus 180.9, that many degrees centigrade. Okay. Kindly read the statement of number 7. Read it? Come on. We have one wire which is fixed at both the ends with the two fixed rigid supports, and it is kept under proper tension. Then we have just provided that wire two pointed supports. Say one support is lying over here, another is lying over here. Then we are asked to find out those positions of these two pointed supports such that the wire, when it starts vibrating with fundamental frequency, at that time the different sections, they vibrate with their own fundamental frequency. At that time there must be one loop in each section, that is, each section should vibrate with fundamental frequency. That is their condition. And for that to happen, what should be the positions of these pointed supports? Let us find out. Suppose these are the correct positions for which the length of this first section I am taking L1, length of second section I am taking L2, length of third section I am taking as L3. In short, we are asked to find out values of L1, L2, L3. Total length of the wire they have given 110 centimeter. Okay, wait. For fundamental frequency, in this case, don't you know formula? V upon 2L, correct? Instead of F1, I am just putting symbol F. Though I am putting symbol F, you must understand right now it is fundamental frequency, which is minimum frequency. In this case, it is V upon 2L. Now take this L over here, so it is F into L, and it will be equal to V upon 2. F into L will be V upon 2. Tell me, the medium is remaining same, so this wave velocity is constant. So this right hand side is constant, so I am writing here constant. Okay. The product of fundamental frequency and length of given section should remain constant. If that product is going to remain constant for all the three sections, then for first section, come on, instead of F I am putting F1, instead of L I am putting L1 for first section. Similarly, for second section you may write F2, L2. For third section I am writing F3, L3. Though I am writing here F2 and F3, don't misunderstand. It is not second harmonic or third harmonic, still it is first harmonic, still it is minimum frequency, still it is fundamental frequency, because instead of F I am putting F2, but what was F? F was fundamental frequency, correct? Though I am putting symbols F2 and F3, you must understand they are the fundamental frequencies respectively in second and third section. Got it? Fine. Now just pick up this much part from this. F1 L1 equals to F2 L2. F1 L1 equals to F2 L2. Find out F1 upon F2. It will be L2 upon L1. L2 upon L1. Now they have given in the statement the proportion F1 is to F2 is 1 is to 2. That is what they have given. Meaning thereby F1 upon F2 will be 1 upon 2. F1 upon F2 will be 1 upon 2. Correct? And L2 upon L1, come on, as it is. Now find out L2. Take this L1 here. L2 equals to L1 upon 2. L2 equals to L1 upon 2. Leave it. And now pick up this part. This equals to this. Correct? So F1 L1 equals to F3 L3. Here it is. F1 L1 equals to F3 L3. Find out F1 upon F3. It will be L3 upon L1. L3 upon L1. And now they have given in the statement this proportion F1 is to F3 is 1 is to 3. Meaning thereby F1 upon F3 will be 1 upon 3. F1 upon F3 you can replace it by 1 upon 3. This right hand side as it is. Find out L3. It will be L1 upon 3. L3 will be L1 upon 3. Here it is. And now what is the total length of the entire wire? It should be summation of lengths of all the three sections. Come on, L1 plus L2 plus L3. Total length they have given 110 centimeter. L1 as it is, but what about L2? L2 is L1 upon 2. L2 is L1 upon 2. L3 is L1 upon 3. L3 is L1 upon 3. And now from this, if you find out L1, it comes out to be 60 centimeter. Fine. Put it here. L1 is 60, so L2 will be 60 upon 2. 60 upon 2, that is 30 centimeter. Put L1 equal to 60 centimeter here. Then L3 will be 60 upon 3. 60 upon 3 will be 20 centimeter, correct? So lengths of first, second and third section are respectively 60 centimeter, 30 centimeter and 20 centimeter. The summation will come out to be 110 centimeter, correct? Fine. Kindly read the statement of number 8. They are talking about two successive harmonics. So if particular order, if you take nth harmonic, very next order will be n plus 1th. You know, in case of stationary wave, nth harmonic is n times first harmonic. Nth harmonic is n times first harmonic, and that particular harmonic they have given 420 hertz, and immediately after that the next harmonic they have given as 490 hertz. But after nth it will be n plus 1th. So instead of n I should write n plus 1. Instead of n here also I should write n plus 1. And that next harmonic they have given 490 hertz. Just take the subtraction, this minus this. When you take this minus this, F1 can be taken common. Inside the bracket, n plus 1 minus n. Come on, this minus this. 490 minus 420. Fine. Now this n will cancel. F1 into 1, that is F1. This minus this is 70 hertz. Now don't you know fundamental frequency in case of stationary wave? What was that? Produced in the string. F1 equals to V upon 2L. F1 equals to V upon 2L. 1 upon 2L as it is. What about wave velocity? In this string, wave velocity for the transverse wave, we had found out the expression using dimensional analysis. Remembered in this chapter? V equals to under root of T by mu. V equals to under root of T by mu. Fine. What about mu? They have given linear density of mass for the string 0.05 gram per centimeter. Fine. Now tension in the string they have given 450 Newton. Now when this value you are taking in CGS, this also should be taken in CGS. So let me convert Newton to dyne. In the first semester you must have remembered 1 Newton we had proved to be equal to 10 raised to 5 dyne. So 1 Newton is 10 raised to 5 dyne. Fine. Now put up the values in CGS. Come on. This frequency we have found out it is 70 hertz. Frequency is 70 hertz. 1 upon 2L as it is. What about capital D? In dyne it is 450 into 10 raised to 5. 450 into 10 raised to 5. What about mu? Linear density of mass for the string. In CGS it is 0.05 gram per centimeter. So this value is 0.05. Simplify. You will get value of L in centimeter 214.2857, that many centimeter. If at all they ask that length of the string in meter, centimeter to meter, divide by 100. When you divide this value by 100, it will be 2.142857, that many meter. But unless and until asked to you, you should not find out that length in meter, leave it in centimeter only, no problem. Okay. Can you read now statement for number 9? Read it? Come on. Here also two consecutive harmonics, they have given respectively 300 Hertz and 400 Hertz. Nth harmonic, you know it is n times first harmonic. Now instead of n, very next order I am taking n plus 1. So instead of n, I should write n plus 1. Correct? Come on, now take the difference. This minus this is equal to this minus this. This minus this, when you take f1, f1, you can take common. Inside the bracket, n plus 1 minus n. N plus 1 minus n. 400 minus 300. Fine. N will cancel. f1 into 1, that is f1. 400 minus 300, that is 100 Hertz. What about maximum amplitude in case of stationary wave? What was the amplitude formula? A dash equals to 2a sin kx. Remembered? And when you are talking about maximum value, on right hand side, sin value you should take 1. So it is 2a into 1, that is 2a. So that is 2a, which is maximum amplitude, A dash maximum. And that maximum amplitude, they have given 10 centimeter. Fine. Now y equals to minus 2a sin kx cos omega t. What is this? This is the equation representing stationary wave. But because that string is oscillating in the first harmonic, that is with fundamental frequency, then instead of k I am putting k1, instead of omega I am putting omega 1. Because order of harmonic is 1. That's why. Come on, minus 2a as it is, sin as it is. What about wave vector formula? It is 2 pi upon lambda. But because it is first harmonic, here I should write 2 pi upon lambda 1. X as it is, cos as it is, omega is 2 pi f. But because it is first harmonic, I am writing here f1 t as it is. Now place the values. Minus as it is, 2a is 10 centimeter. 2a is 10 centimeter into sine of 2 pi as it is. What is lambda 1? It is the biggest wavelength in case of stationary wave. What was the lambda n formula? Lambda n equals to 12 upon n. Put n equal to 1. Lambda 1 equals to 12 upon 1, that is 12. When lambda 1 is 12, it is the biggest wavelength. Remember, lambda 1 is 2 into L. Lambda 1 is 2 into L, where L is the length of the string. They have given 100 centimeter. X as it is. Cos of 2 pi as it is. What about fundamental frequency? We have found out it is 100 Hertz into T. Fine. Now this minus 10 as it is, sine as it is, 2 will cancel, pi upon 100 into x into cos of 100 into 2, that is 200 pi, that many t and that many centimeter. Because this value we had taken in centimeter, naturally this displacement will be obtained in centimeter. Got it? Fine. So this is the required wave equation for stationary wave, okay, where x and t are variable, and so unless and until given the values of x and t, you cannot put them. So leave the final equation like this only, okay. Read down number 10. Read it? Come on. There is one stationary listener. Because L is at rest, I am putting VL equal to 0. And there is one car in which the horn is blown, and that's why it produces sound. So we can take that car as source of sound. Source means S. Initially, this car is approaching towards the listener, and then after it recedes away from this listener. First of all, it is moving towards the listener, and then after away from listener. In both the cases, we are asked to find out the frequency of sound heard by the listener, and then after we have to find out the difference in the two frequencies. Let us find out. Let us take first case in which this car is moving towards the listener. Fine. Velocity of source means Vs. That velocity they have given 54 km per hour. 54 as it is. Kilometer per hour, you must convert into meter per second. Multiply by 5 divided by 18. 18 3 is a 54, 3 5 is a 15 meter per second. Fine. Standard formula, FL upon V plus VL equals to Fs upon V plus Vs. Fine. FL as it is. What about velocity of sound? They have given 340 meter per second. Because listener is at rest, VL is 0. VL is 0. This is the frequency of sound actually generated from the source. That frequency they have given 500 hertz. What about Vs? You know from sign convention, velocity in a direction from listener to source should be taken positive. Because this direction is opposite to this value I should take negative. So value of Vs is plus 15, but according to sign convention I should take it negative. I am supposed to take this value negative because this direction is opposite to direction shown in the sign convention. Come on, Vs is minus 15 now. Vs is minus 15, correct? Fine. Simplify, find out value of FL. You will get it 523.076, that many hertz. This is the frequency of sound heard by the listener when car is moving towards the listener. Okay. What will be the frequency when car is moving away from the listener? Let us find out in the second possibility. Number 2, listener is at rest, so VL is 0. Now car is moving away from the listener. Car means source. Source is moving away from the listener. Velocity of source I am putting Vs. Wait. According to sign convention, velocity in a direction from listener to source should be taken positive. So right now this direction you can see it is same as this direction. So I am supposed to put the value of Vs as positive. Fine. Come on, standard formula, FL upon V plus VL equals to Fs upon V plus Vs. But right now this frequency heard by the listener, it is somewhat different than earlier frequency. I am putting different symbol. FL dash, wait, FL dash I want to find out. Upon V plus VL, V is velocity of sound, it is, they have given 340 meter per second. What about VL? VL is 0, VL is 0. And that equals to frequency of sound actually generated from the source, they have given in the statement 500 hertz. What about velocity of sound? 340 meter per second. What about Vs? This direction is same as this direction, I should take its value positive. So I should write plus 15 meter per second. Simplify, value of FL dash, you will get 478.87, that many hertz. And now they have asked the difference in frequencies, that is greater minus smaller. Greater value is FL, smaller value is FL dash. FL minus FL dash, come on, take the subtraction, you will get the final answer 44.206, that many hertz. Here they have asked difference, but in the examination they may ask the ratio also. So please read carefully actually what is asked in the question. Okay, please. Come on my dears, now read this statement of last example number 11. Read it? Fine. We have one engine from which the whistle is blown, means sound is produced. So you can take that engine as source of sound. That's why I am writing here S. And because sound is actually generated from that engine, you can take that engine as real source. Okay. Now at some distance from this engine, we have got one hill or cliff. This cliff means this slope is very large and almost the surface is vertical. That sort of hill is called cliff. Fine. Now what will happen when the sound is produced from this engine? Those sound waves will be made incident and naturally it will be getting reflected. That reflected sound wave is known as echo, E-C-H-O. Reflected sound wave is called echo. What would be the frequency of reflected sound as heard by the engine driver? That is what is to be found out. Okay, let us find out. Now in this case, what you should do, when they are asking the frequency of reflected sound, what you should do? You should consider some imaginary source on the opposite side of real source. If real source is on the left side of the hill, then you should consider imaginary source on the right side of the hill. Okay. One more thing. Whatever is the speed of real source, same should be taken speed of imaginary source, but just in opposite direction. This velocity is toward right hand side, This velocity is to what? Left hand side. Let it be V.S. dash. And one more thing. Up till now, which formula you are using? FL upon V plus VL equals to Fs upon V plus Vs. But now instead of Vs, we should take Vs dash. Because this reflected sound is, you may consider as if it is coming from this imaginary source. If this reflected sound is coming from this imaginary source, then you should make one change here. Instead of Vs, you must write Vs dash, that is velocity of imaginary source. Okay? And last point, up till now in the sign convention, what we were saying, velocity in a direction from listener to source should be taken positive. Here what you should say, velocity in a direction from listener to imaginary source should be taken positive. Velocity in a direction from listener to the imaginary source should be taken positive. Now you may surprise that why I am considering listener here, because there is engine driver also inside the engine, and then that engine driver is going to listen that sound. The person who does the job of listening is called listener. So this is source also, and same is listener also. So velocity of listener and velocity of real source, they are equal. Now you just speak out again. Velocity in a direction from listener to imaginary source should be taken positive. Fine. Now just dictate me the values. This is FL means what? Right now it is frequency of reflected sound heard by the listener. Frequency of reflected sound heard by the listener, which we have to find out. What about wave velocity? Velocity of sound wave, they have given 340 meter per second. What about VL? Velocity of listener means velocity of driver, means velocity of engine. Velocity of engine is in the same direction as of that sign convention. Because these two directions are same, this velocity I should take positive. Come on, velocity of engine, they have given 10 meter per second. Here I should write VL equals to plus 10 meter per second. This is frequency of sound actually generated from the source. That frequency of that whistle, they have given 660 hertz. Velocity of sound is 340 meter per second. What about Vs dash? Take care now. This velocity is opposite to this. Come on. If it is opposite to this, then you should take it negative. Come on. This velocity, magnitude wise, it is same as this. Come on. What was the magnitude of velocity of real source or engine? 10 meter per second. So here also this speed is 10 meter per second. But because direction is opposite to this direction shown in the sign convention, we should take it minus 10. So Vs dash is right now minus 10. And now simplify. Answer of FL is 700 hertz. Correct? Then you may have a question, why we are taking this velocity opposite to this? The reason is that as time will passes on, what will happen? As time will pass on, what will happen? This engine will go closer and closer to this cliff, will go closer to this hill, and when it goes closer and closer to the hill, what will happen? The consequently generated sound waves will have to travel lesser and lesser distance, while being incident also, and then after while getting reflected also, correct? So if the consecutively generated sound waves have to travel lesser and lesser distance, then meaning thereby echo will be heard quicker and quicker. Echo will be heard quicker and quicker, and meaning thereby if echo is heard quicker and quicker, then you must say that echo from whichever source is coming must be approaching towards the listener, correct? So if echo is heard gradually quicker and quicker, meaning thereby this reflected sound which is considered right now coming from imaginary source must be approaching towards the listener. That's why its velocity we take towards this listener. Got it?